Hi friends, welcome to my channel. I hope everyone is doing good. Today we are going to solve another very popular and frequently asked coding question. It's on Leetcode 692 top K frequent words. So this is a medium complexity coding problem. So we are going to discuss this problem. I created some examples as well as one interesting solution that you are really going to like. So make sure you watch this video until the end so you completely understand that solution as well as its implementation. If you are new to this channel, please subscribe to this channel now. It really helps and supports this channel. Here we create videos to help others in their Java and coding interviews. So let's start. Given an array of string words and an integer k, return the k most frequent strings. Return the answer sorted by frequency from highest to lowest. Sort the words with the same frequency by their lexicographical order. Right? So this is what the problem statement says. So we'll go through the constraints once just to take a look. So words dot length can be 500. So 500 maximum words will be there in that array. And then the length of the word can be maximum 10 and it will contain lowercase English letters, and k is in the range 1 to the number of unique words. Okay, so let's take a look at this example so you will know what they are saying. So these are the examples, right? So these are couple of words that are given to us, right? And what they are saying is we want to find out the top maximum frequency two words in this, right? So maximum frequency basically, right? So what is the maximum frequency of I come two times, so its frequency is 2, right? Love come two times, its frequency is 2. Lead code is 1 and coding is 1. So I and love has a frequency 2. So lexicographical order. So I should come first and then L, right? Love. So these are the two most frequent words. K is equal to 2. It means that we want to find out the first two words, most frequent words, right? First two most frequent words. Okay. Here is another example here. So here the comes how many times? So the is here, here and here. So the comes 4 times, right? So it is, so we want to find out the top 4 most frequent words. So the is there, right? So the is appearing maximum number of times. So it is appearing 4 number of times, right? Okay. What is the other word? Is appear here, is appear here, and is appear here. So is appeared 3 times, correct? Okay, so its frequency is 3. Sunny appeared 2 times, right? So sunny's frequency is 2. So you are seeing it, right? How we are going it here. Day appeared 1 time. So day appeared 1 time, then day will be the last one here, right? So these are the most frequent word and they are sorted according to their most frequent. So most frequent is the here, then is, then sunny, then the, right? Then day, then because the appear 4 times, is appeared 3 times, sunny appeared 2 times, and day appeared 1 time, right? So this is what the problem statement says. So now I hope you understood what they are asking us to do. So pretty clear statement. So we want to find out the most frequent keywords, right? So how can we solve this problem? So it means that we have to somehow go through these words, right? Through these words that are given to us, and we should keep track of how many times that word appeared actually, right? We must know that. So here I am going to show you one solution where we can use a try data structure. So here is an example of a try data structure. So you can understand this first clearly, and then we can so this is a sample try data structure, right? So you must be familiar with a try data structure. So it is like a tree, but it is pronounced it as a try, try, right? So this is how you pronounce this data structure. Okay, so if we have these words, right, these are my words, and if I want to insert the words into my try data structure, so there will be root here. So let's say root, and root will point to, let's say, L, right? So I inserted lead code, then lead, and then, so let's say if I insert lead code here, right? So this is how the try data structure will insert it, LEET CODE, right? So this is how the try data structure insert it, correct? and at the end you will mark this as a ending is equal to true, because that word ends there basically, right? And it also, what we will do to solve this problem is, we also need one thing here, right? What is that one thing we need? We also need how many times that word is coming. So for that, what we will do, we will also insert one counter here, right? One counter. So how many times that word is coming? So I will say that C is equal to 1 here, right? So the word appeared once here, Leetcode, right? When Leetcode is, I am inserting again here and here, what I will do, I will again go through it and I will find that it's already here in my try data structure. All I have to do is increment the count, right? So after I insert Leetcode 3 times, my count become 3. So this is a very important thing, right? Because we want to know how many times that word is coming. So now we know that that word Leetcode is coming 3 times in my try data structure. So how try data structure work? For each node you can have maximum 26 children. Why only 26? Because in English alphabet you have uh, 26 smaller case letters basically, right? So for example, I have a node A, right? I have a node A. So for the people who doesn't know try, I'll quickly tell them, okay, so they will know this. So I can have maximum 26 children. Let me show you. So A, then for example B, here its children, then C, and so on, right? And then Z. So this is the maximum possibility that a child can, that a parent can have so many children, 26, maximum 26, because in English there are 26 alphabets, right? Okay, so this one you understood. So now we we already inserted the lead code word 3 times. Now we will insert lead. So this is the lead and this is the lead. So it is coming 2 times. So here is the lead, L, E, A and D, right? So lead is coming 2 times. So what we will do, we will put one counter here and counter is equal to 2. It means that this word lead is coming 2 times. So we will know how many times that word came basically, right? The word less is coming 1 time, so you insert this word less here, less, right? And you will mark this word as a count is equal to 1, correct? Count is equal to 1 because it only came 1 time, right? And then lemon is here, right? Lemon is here, so you will insert lemon, correct, in your try. This is a try data structure, okay? And for this last node, what you will do, you will mark that this is where the word is ending is equal to true, but you will also mark that the count is equal to 1. It means that the word is only came once. Okay, so far so good. So you understood this concept clearly. So what we have done so far, so we have taken all the words and we have inserted those words into our try data structure, and for each of the word ending we also marked how many times that word came, which is with the counter, right? Counter. So far so good, you understood this much. Now what we will have to do, we want the top k words, top k words. So for that we can use priority queue, and so priority queue will use it as a maxif, right? Because we want maximum frequency first. So what is the maximum frequency first here? Leetcode. Its frequency is how much? 3. So we will insert these words from our try data structure. These try nodes we will insert into our priority queue. So this is your priority queue, right? So PQ basically, right? And you insert these nodes with the highest priority. It will keep highest priority first. So what word you will have first here? Leetcode you will have first, right? Because its frequency is maximum, right? Then the second frequency will be lead, right? Then you will have lead, lead, right? Okay, like this basically, right? So its frequencies 2, this frequency is 3, and so on. So maximum frequency will be on the front side, top front side, right, of the priority queue. This is a maxi, right? And then you just take out the k elements from it, and then it should solve this problem basically, right? So this is how you can use a try data structure to solve this coding problem. So I hope this is very clear with you now with this example and explanation. So now is the time to go through the Java code and understand how to implement this one. So let us go to the Java code. I'll first show you how the try will look like, the try data structure will look like, so that it will be clear for you. So this is our try class, right? So it has a final static number of characters are 26, because I told you 26 alphabets, right? And this is a try node, right? This is a try node class. Try node is basically a node, right, of the try. So what it has, it can have a children, right, or maximum 26 children it can have. Now this is very important. End of word I showed you here, right? End of word. So end of word means that that word is ending. So this, at this e node, this word Leetcode is ending basically, correct? So that's what it is for. Count is the frequency, how many times that word came, and string is the actual word, right? So we'll capture that actual word here that we have inserted at this node, right? Leetcode you inserted, so you have to capture that here at the end of the node, basically last node. Okay, and this is the constructor of try node. So end of word is false, count is 0 in the beginning, string is empty in the beginning, right? Okay, root is the try node, and then we will have a add method where you can add the key or add the word into the try. So this is the standard implementation of a try, where you have to just basically check if you have those nodes. Otherwise, if node doesn't exist, what you will do, you will create a try node if the node doesn't exist, and then you will keep iterating through this for loop and keep inserting those nodes. So int level, int length is equal to key dot length index. So these are the things that we will be using in this add. So basically, when you are adding, so let me remove all this. So now you understood this concept clearly, right? So now what I mean to say is, if I want to add, let's say, a word called as um LET, right? LET, I want to add a word, LET, late, right? So what we do in try is, first you check L. L is there, yes, as a node, right, of root, yes. Then you go to E. Is E there? Yes, E is there here as a child of L. Then you check for T. Is T there as a child of E? No. Then it means that you will create one child node here, basically, right, for T, right? And then you will just insert it here. So that is what exactly we are doing it here, right? So in this for loop. Okay, so you are going through all the like characters and checking if that node does not exist. So current dot children of index, if it is null, it means that that node does not exist. Then you create that node. So then you will create a empty try node there, and you will just use current is equal to current children of index, basically, correct? So this is what we are doing here, as I said you, right? So this t node you are inserting, and here you will mark ending is equal to true, and then str string is equal to late, right? And the count is equal to 1. So that's what you do basically. So current dot end word is equal to true, then current dot count is equal to current dot count plus 1, because this word now came one more time, basically, correct? One more time, so you are increasing its count. And your string is equal to the key is the word that you inserted into the try data structure, right? Okay, so this is just a standard way how you can insert a word into try. I have some other videos also. I'll give you the link below the description, so you can check out the try data structure in more detail. But this is just pretty simple code where we are just creating a we are just inserting a node into the inserting a word into the try data structure. Okay, and then here is the key where we are actually going to traverse the try, and then we are going to add that node into the priority queue. Okay, so you take the root of the try data structure, you have a priority queue of try nodes, right? So if root is equal to null, you will simply return. This is a recursive function, right? So this is the base case of the recursion. Okay, so root is null, you simply return. Otherwise, if your root is uh, end of the word, right, then you will add that end of the word, means you will add that into your priority queue. For example, when you reach this n, right, this n, this is the end of the word lemon, so you add that into your priority queue. When you reach this e, it is the end of the word Leetcode, so you add this into your priority queue. This node you add into the priority queue. Okay, this is a node, this is a try node, right? Otherwise, what you will do, If it is not an end of word, then it means that you have to go and find out the children basically. So you are recursively calling the traverse function, and what you are passing the child of that root node. So there can be 26 children maximum. So you have to do for 26 times, right? Num cars is 26, okay, and then 26 times you will pass, and you will pass the priority queue here, right? So at the end of this traverse function, you will have these values added into your priority queue. What values? These values, right? These two I already showed, 1 2, this is 3, and this is 4. So this will be into your priority queue. Each value will be sorted according to the priority queue. The maximum frequency will be on the top, right? So why it will be on the top, I will show you that now. So this is our top k frequent method, right? So what is given to us, which is array, k value is given to us. So first we will create one a try data structure instance, right? This is the object of try. Then we are going to go through each word and insert those words into try here. And here is the priority queue that I was talking about. So here we are defining a priority queue of try nodes, but how do we want to sort it? So we are specifying that in the constructor of this priority queue here, right? So a comma b, if a dot count is equal to b dot count, it means that those words are appearing same times. Then we want to sort them on lexicographical order, because that's what they are saying here. Sort the words with same frequency by their lexicographical order, right? So we will just do a dot string compared to b dot string. So we are sorting based on the lexicographical order when their frequency is matching. Otherwise, you will just do b dot count minus a dot count. It means that maximum count will be on the top of the priority queue. Okay, it's a maxi. Okay, so this is how you define that priority queue. Now we will just call that traverse method that I just shown you. We'll pass the root of the try and we'll pass the pq. It will insert all those nodes into the priority queue. Which nodes? Where it is ending, this node, this node, this node, and this node, where it is ending node. Okay, and then now is the time to actually find out that top k words, right? So we will create one list of result, and we'll start iterating through our priority queue. So while priority queue is not empty and k is greater than 0, we will remove that word which is maximum frequency word from the priority queue here. Then we will get the word by using current dot string. It will give you the word, and you add that word into your result k minus minus, right? So you loop into this while loop, and it will you are trying to get the top k words from the priority queue and add it into your result, and at the end just return the result, and this should solve the problem. So this is how you will write this code using the try data structure. I explained you in a fair detail of how it works. So now is the time to check it out if it passes the test cases. And as you can see, the test cases are being passed here. We are getting correct result here, right? Submit this code to the Leetcode. Make sure the code gets accepted by the Leetcode. And as you can see, the code is successfully accepted by the Leetcode. It is 97.76% faster than other performances, which is a very good solution to solve this coding problem. 692 top k frequent words, a medium complexity coding problem on Leetcode that we have solved with the help of a try data structure that I shown you here and a priority queue, right? So I hope you learned how to use try data structure to solve these kind of problems, and how to use a priority queue as a maxi. And if you understood this problem clearly with this example and this explanation, then please give it a thumbs up to this video, give it a like to this video, subscribe to this channel. Your subscription is really valuable and important for our channel. It really helps and supports this channel. It takes lots of efforts to create these videos with this image, with these examples coming up, with these examples, and explain it to you guys. So if you really want to appreciate these efforts, then try to be generous and give it a like for this video. Subscribe to our channel, click on the bell notification icon button right away, so you won't miss any important upcoming postings from our channel. Here we create videos to help others in their coding and Java interviews. More than 550 important coding problems are solved. The most important playlists for you on this channel are graphs, matrices, binary search trees, binary trees, Problems solved using binary search, dynamic programming, recursion, memoization, how to use and apply BFS and DFS on trees, graphs, and matrices. And important data structure playlists for you are stacks, queues, priority queues, min heap, and max heap. Go through them. You are going to learn a lot from them, and they will definitely give you a good preparation for your interview rounds. Share these videos with all your friends and colleagues so they will also come to know about this channel. They will also watch and learn from these videos. And thanks for watching this video and have a great day ahead.